Hey guys, welcome to the Cynohub. Today we will discuss one of the important topic which is central limit theorem, which is part of our machine learning. See here, this central limit theorem, by the name itself, we can write it as CLT in a short form. It is one of the crucial pillar of statistics and machine learning. It is at heart of the hypothesis testing. Okay, so here some of the concepts which are taken from the probability and statistics. So here central limit theorem is one of the important topic from the statistics which are taken into the part of machine learning. Okay, see here exactly what is that central limit theorem. See that the central limit theorem is a statistical theory that states that if you take a sufficiently large sample size from a population with a finite level of variance, the mean of all samples from the population will be roughly equal to the population mean. See one example. Consider there are 15 sections in class 10th and each section has 50 students. Our task is to calculate the average marks of student in class 10th. See, then what we will do, then generally we will follow the standard approach will be to calculate the average sample simply. See here. First we will calculate the total marks of all the students in class 10, total marks. Second one, adding of all the marks. And third one, divide the total marks by the total number of students. So by that we will get the thing. But that is the general scenario we are going to following. So by that, what we will get? See here. But what if the data is extremely large? Okay. Now we are taking only 15 sections. For example, if it is in 100 sections, then it will be a so many number of thousands of the students will be there. So that is going to become as a extremely large. At that particular moment, what we will do? See here. Is this a good approach? No. Then the calculation marks of all the students will be a tedious and time consuming process. So what are the alternative? Let us look into the another approach that we can call it as central limit theorem. See here. To begin, select the group of students from the class at random. This will be referred to as a sample. Create several samples it with each with 30 students. One sample we are going to create. Next, calculate the each sample's individual mean. Calculate the average of these sample means. The value will give us the approximate average marks of the student in class 10. The histogram of the sample means marks of the students will resemble a bell curve or normal distribution. So by that, if it is a large amount of data, when we are going to calculate in that one, at that particular moment, the central limit theorem is going to play very much important role. Now coming to the actual significance of the central limit theorem. See, the CLT has several applications. Look at the place where you can use it. See here. Political and election polling is a great example of how you can use CLT. These polls are used to estimate the number of people who support a specific candidate. You may have seen these results with confidence intervals on the news channels. The CLT aids in this calculation. So this is one of the practical application point of view. CLT is going to play very much important role in our political election thing. Now coming to the exactly what it means that central limit theorem. See here, the central limit theorem, it is an important finding and pillar in the field of statistical probability. So in this, a sample of a group of observation from a broader population of all the possible observations that could be made given trials. See here, first one is the observation, second one is the sample, and third one is the population. See here, observation. Result from one trial of an experiment. Sample group of results gathered from separate independent trials, and the population space of all possible observations that could be seen from a trial. This is the another set of example that shows the importance of the central limit theorem. Now we will describe our central limit theorem with the help of exact statement. See here, the central limit theorem establishes that when independent events are added, the sum tend towards a normal distribution that is going to be showing in the form of bell curve, even if the original variables themselves are not normally distributed. See here, this provides a way to understand characteristics of a population of data points using only samples taken from that population. Now coming to the mathematical point of view, in mathematical terms, how we are going to representing. See here, the number of, first we are going to taking number of random samples. Next we are going to taking the sample mean. Next standard normal distribution, and finally standard deviation. See here. So here this is the random sample we are going to representing with the help of capital H, sorry capital X. So in that we are going to showing that samples x1, x2, x3 up to x suffix here. Next, z is the mean, that is the z is equal to x bar suffix small n minus mu by and sigma by root of small n, as n always tends to infinity. Okay, where see here x is a group of random samples and x bar is sample mean and small n is the number of random samples and capital Z is the standard normal distribution and sigma is the standard deviation and mu is the mean and the symbol is infinity. So by this we are going to representing this is our final equation. Coming to your external examination point of view, describing all those things. So finally representing this particular equation by describing the terms within that one, you will get a very good marks. Okay guys, I hope you understood this video well. We will meet once again in the next video.